Welcome to the Critique. Today we're looking at a really dense piece, analyzing the interstellar object's three-eye atlas. It covers its recent activity, those anomalous characteristics, especially the brightness spike around October 3rd, and, well, digs into various hypotheses, including a potential technological origin.
Right.
Let's just jump straight into the assessment.
Okay. Well, first off, the quality here is, it's exceptional, really. You can see the immense effort that went into pulling together complex, real-time data, synthesizing the chat from astrophysicists like Marshall, Thomas, Trigo, and consolidating some really granular findings. Things like the early CO2 coma, way out past 5AU, that extreme negative polarization, the level 2 data stuff. I mean, the scientific groundwork is definitely solid.
Absolutely. And that foundation, that's why this piece has so much potential. But, we do need to talk about some structural things that are kind of holding it back from having its maximum impact.
Yeah, I see that too.
The first big one, and probably the most critical, is focus.
Okay.
The overall impact of the three-eye atlas analysis is significantly diluted by the incorporation of several disparate and unrelated narrative tangents.
Right. I think that's the core issue. It kind of undermines the authority that the author builds up so carefully elsewhere. I mean, you get these really deep dives into the science.
Yeah.
The October 13th data discrepancies, the physics behind the October 3rd O-burst, that whole debate about sublimation versus rupture for the tail, that's the good stuff.
Yeah.
That's the high-stakes science drama we came for.
Exactly. But just when that scientific tension is building, the listener's sort of forced to pivot, like completely abruptly. Multiple times. You veer off into talking about, personal disputes over copying video footage or titles from some storytelling planet.
Right, yeah.
And then these long philosophical sidebars on free will, reincarnation, mentioning the exiles of Capella. And then suddenly, we snap back to talking about the object's velocity. It's whiplash.
And it's not just that there are tangents, it's the shift in tone. Right? You go from this really rigorous, careful scientific voice, analyzing CO2 comas and level 2 data.
Yep.
And then, bam, you're hearing about interpersonal stuff. It just fractures the whole thing, weakens that scientific authority, and honestly, it makes the listener have to keep resetting. It feels longer and less focused than it should.
So, the suggestion here seems pretty clear. Segment the material based on the type of content. Keep the main piece purely for three-eye atlas data, the analysis, and, the related scientific speculation.
I wonder, though, if we pull all the philosophical stuff, do we lose some of that unique flavor the author was maybe going for? Maybe it's not about total elimination, but just ruthless containment?
Yeah. Maybe isolation is a better word than elimination. You could keep it somewhere else on your platform. But for this core piece on three-eye atlas, you need a single, focused story.
Okay.
It needs to move smoothly from those initial detection anomalies, the early CO2, the high flux factor, right through the Mars flyby, the critical October 3rd analysis, and then into the perihelion predictions. That chain cannot be broken.
Okay, so concretely then, pull out the side stuff, the channel copying grievances, the really deep philosophy dives on Earth as a prisoner, whatever. Move those to maybe a separate Q&A or a companion piece?
Absolutely. Give the science its own space to breathe, its own authority. Look, if you feel you must connect them, maybe use one single, powerful analogy from the philosophy at the very end, something that informs the conclusion. But don't give us the multi-paragraph breakdown of the source text within the main analysis.
Right. Okay, that makes sense. Sharpen the focus.
That structural fix alone will make a huge difference. It goes from a confusing mix to a powerful, focused scientific piece.
All right, let's move to the second big opportunity. Now that we've cleared out the noise, let's look at how the main narrative actually builds towards its most, let's say, ambitious point, the tech hypothesis.
The material clearly identifies key scientific anomalies, but the transition to the low-probability technological hypothesis lacks the necessary narrative bridge linking the strange data points to the proposed alien objective.
Yeah, this is a critical gap. The piece does a fantastic job detailing the weird stuff. I mean, the most extreme negative polarization ever seen in a comet? That's wild.
Right.
And the early detection of nickel without iron? Very unusual. Then suddenly, bam, loads of water vapor later in September. These are amazing scientific hooks. They just scream something weird is happening here.
They absolutely do. That's the evidence. But then, when the narrative pivots to the tech idea, the focus shifts completely. It jumps to the destination, Jupiter, Ganymede, and lists reasons why that makes sense. Low gravity, resources, Trojan asteroids nearby.
Okay.
Right. We need to actually use those scientific oddities to justify taking that leap, even while acknowledging, as you do, that the probability is tiny, like 0.001%.
Exactly.
So the suggestion has to be, use the specific anomalies discussed, particularly things like the magnitude discrepancy or the odor burst, as the evidence points that the technological hypothesis needs to explain. That's what justifies including it despite the low odds. Comet picture. Like, take that October 3rd brightness spike, the O burst, and that 2 magnitude difference Thomas saw on the 13th, compared to the level 1 numbers. If, and it's a big if those aren't just errors in subtracting the sun's background glare, then they represent something real, some sudden variability that doesn't quite fit normal sublimation.
And that's the potential opening. You need to frame that variability, that sudden brightening, as maybe, just maybe, representing a small, early engine burn, a tiny thrust, or some kind of maneuver needed for a course correction.
Right.
We know it's heading for Jupiter in 2026, so if the goal was controlled flight to Ganymede, you'd expect maybe small early tweaks to line up that gravity assist just right. That connects the observed weirdness, the O-burst, directly to the proposed objective nudging the trajectory towards Jupiter.
And we could do the same thing with the composition. Instead of just saying, lots of CO2 and nickel early on, that's odd, ask the question, could this unusual mix point to something engineered, like a specific type of shielding?
Ah, interesting.
Maybe a nickel-rich outer layer is exactly what you'd need to survive an intense perihelion pass and execute a big Oberth maneuver to change course dramatically.
So you tie the anomaly, the nickel, to the potential action surviving that maneuver. Okay, I see. It shifts it from just, this is weird, to, this is weird in a way that could actually help the technological mission.
Exactly. It makes the strangeness functional to the hypothesis, not just random noise.
Got it. That strengthens the speculative bridge considerably. Okay, so let's talk about the third and final critique. This brings us back to the technical details and how we communicate uncertainty. It's about scientific suspense, really.
Well, meticulously defining complex jargon, the material moves too quickly through the consequences of data limitations, dampening the gravity of the current uncertainty surrounding the October 3rd event.
Ah, okay. A pacing issue with the technical bits. You're saying the definitions are there, but maybe too fast or not enough emphasis on the implications?
Pretty much. Look, you clearly have the knowledge. You define the crucial difference between level 2 data, the process stuff Thomas used, and level 3 data, which is more refined but wasn't available for background subtraction yet. That distinction, that's everything. That's the whole scientific debate right now.
Right, that's the key.
But that absolutely critical point gets kind of drowned out, because it's immediately followed by this rapid-fire list of other definitions: FUWM, elongation, aperture photometry.
Okay, yeah, so the main takeaway, the fact that we literally cannot confirm if the October 3rd O-burst was real until we get that level 3 data, which might explain the huge brightness discrepancy, it just loses its punch. It gets lost in the glossary section, essentially.
You're telling the audience we're right on the edge of knowing something amazing, but then you rush them past the view.
Okay, so the suggestion then is, dedicate more focus to synthesizing the reason for the conflicting data and why level 3 is so essential. Emphasize that the technical limitations themselves are the main hurdle, the main source of suspense.
We need to almost dramatize the weight. Why is level 3 so critical? Well, because making this measurement is incredibly hard.
Right.
You're trying to pull this tiny signal out from the massive glare of the sun. And the fact that the object was seen at such low elongation, like 12 to 30 degrees away from the sun, makes subtracting that background incredibly tricky. It's like trying to hear a whisper next to a running jet engine.
Yeah, good analogy. So how to improve it? You're saying after defining the data levels, pause. State clearly,
Look, the main ideas about what happened on October 3rd sublimation burst, chunk breaking off, maybe even it's all preliminary because of this measurement challenge.
Exactly. Emphasize that the viewing angle makes the brightness readings prone to significant uncertainty, maybe 0.2, 0.3 magnitudes. That's what level 3 processing is supposed to fix. Make that clear.
And maybe use the visual context to drive it home. You mentioned the C-core and stereo images showing intense solar-wind interaction around then.
Perfect. Use that. Show why sophisticated background modeling is so vital. Make the audience feel that technical difficulty. Make them understand that until level 3 arrives, any conclusion about October 3rd, natural or otherwise, is basically an educated guess.
Okay, that really amps up the suspense and gives more weight to the caution shown by people like Marshall and Thomas. It makes the science feel more alive, more uncertain, in a compelling way.
Precisely. Look, this submission is genuinely strong on the technical reporting side. Really impressive work. It's just held back a bit by the structure and the pacing of how it's delivered. So we've highlighted these 3 main areas.
Right. And the primary advice, the thing that kind of underpins it all, is segmentation. You've just got to ruthlessly segment the content. Keep the main focus purely on the 3I Atlas science.
Yeah.
Separate out the personal stuff, the deep philosophy. Keep that for another time or place to maintain that scientific authority.
And secondly, make sure that when you do bring in the high-level speculation, like the tech hypothesis, it's always directly tied back to the observed anomalies. Use the nickel, use the O-burst, use the polarization as your justification.
And use the current data limits that wait for level 3 as the core mechanism for building scientific suspense. Don't rush past the uncertainty. Lean into it.
Absolutely. If you can implement those structural and narrative tweaks, clean up the signal, as it were, this analysis will really hit hard.
Agreed. It's close. We definitely encourage you to take this feedback, revise the material, and please do submit it again. We'd love to take another look.
Yeah, absolutely. We look forward to seeing the update. Until next time.